Have you ever been sitting in bumper-to-bumper traffic, opened Google Maps, and seen that angry red line on the highway and wondered, wait, how does my phone already know I'm stuck here? Like, you just got on the highway 30 seconds ago. There aren't helicopters following you around. So, how does Google Maps know in real time that you're crawling along at 12 miles per hour instead of cruising at 65? Here's what nobody tells you about this. It's not satellites watching you. It's not traffic cameras feeding data to Google, and it's definitely not some all-seeing AI in the sky. What's actually happening is way more interesting, and honestly, a little bit wild when you realize how much of your digital life is quietly working in the background to make this possible. In the next 15 minutes, you're going to understand the invisible system that turns millions of phones into the world's most accurate traffic reporting network. And once you see how it works, you'll never look at your morning commute the same way again. So let's talk about traffic for a second, because here's what's really happening. Every time you're late to work, cursing at the cars in front of you, you pull out your phone, you open Google Maps, and immediately, like instantly, that map shows you exactly where traffic is terrible. Red lines on the highway, orange patches through downtown, green everywhere else. It knows, but how? Think about it this way. 20 years ago, if you wanted traffic information, you'd turn on the radio and wait for the traffic report. Some guy in a helicopter would tell you about a backup on the 405. Maybe you'd catch it, maybe you wouldn't. But now your phone knows about that backup before the helicopter guy does. It knows about traffic on random side streets that helicopters never even look at. It knows about a fender bender that happened 2 minutes ago on a rural road outside Columbus, Ohio. Everyone assumes it's traffic cameras. That makes sense, right? Cities have cameras at intersections. Google must be tapping into those feeds, analyzing the footage, and mapping out traffic patterns. Except, here's the thing. Most cities don't share that camera data with Google. And even if they did, cameras only cover major intersections. They're not on every street. They're not on highways between cities. They're definitely not on that back road you take to avoid the highway traffic. So that's not it. And this matters because traffic data has quietly become one of the most valuable pieces of information in your daily life. It determines when you leave for work, whether you take side streets or stick to the highway. It affects whether you're on time for that job interview or 15 minutes late. It's not just about convenience anymore. It's about reclaiming actual hours of your life that would otherwise be wasted sitting in a car going nowhere. Here's what's actually powering Google Maps traffic data, and this might blow your mind a little bit. It's you and me and basically everyone else with a smartphone in their pocket. Google Maps isn't watching traffic from above, it's tracking millions of phones moving through space in real time. Your phone right now, if you have location services turned on, is constantly pinging Google with your GPS coordinates. And Google is looking at how fast you're moving. Think about what that means for a second. When you're on the highway moving 65 miles per hour, your phone knows that. When you suddenly slow down to 30, then 15, then you're basically stopped, your phone knows that too. And it's not just your phone, it's every single phone on that same stretch of highway, all reporting their speeds simultaneously. Google takes all of that data, combines it, and creates a real-time map of where traffic is flowing and where it's stuck. This is what I call the crowd speed effect. Instead of trying to watch traffic from the outside, Google turned every driver into a tiny traffic sensor. You're not just using the map, you're creating the map. Every time you drive with Google Maps running, or honestly, just with your location services on, you're contributing to a massive collective data set about traffic patterns. And here's where it gets interesting. Google doesn't need everyone on the road to be sharing data for this to work. They just need enough phones that they can establish patterns. If 50 phones are all crawling along the same highway segment at 12 miles per hour, Google knows that's not because 50 people all decided to drive really slowly. That's traffic. The math is actually pretty simple. Take the average speed of all the phones on a road segment. Compare it to the normal speed for that road. If there's a huge difference, boom, traffic. But wait, because this next pattern is particularly sneaky. Google isn't just measuring speed, it's also tracking something called probe density. This is the number of phones per mile on any given road. And this matters because it helps Google figure out the difference between a road that's empty and slow versus a road that's packed and slow. Picture this scenario. You're driving through a residential neighborhood at 25 miles per hour. That seems slow. But if Google Maps only looked at speed, it might think that's traffic. Except there's only one phone yours on that whole street. Low density, slow speed, that's just a residential road with a speed limit. But if there are 30 phones all moving at 25 miles per hour on a highway where the limit is 65, high density, slow speed, that's definitely traffic. Your brain actually does this same kind of pattern recognition all the time. Back when we were hunter-gatherers, we had to figure out if a bunch of animals clustered together meant food or danger. We'd look at how they were moving and how many there were. Google Maps is basically doing the same thing, except instead of animals, it's phones. And instead of survival, it's helping you avoid being late to brunch. Now, this connects to something even deeper. Google doesn't just collect data in the moment and forget about it. They're storing historical patterns for every single road segment they track. They know that on Tuesday mornings at 8:30, this particular highway is always a nightmare. They know that Friday afternoons are worse than Monday mornings. They know that traffic before Thanksgiving is absolute chaos, but the week after New Year's is weirdly smooth. There's this pattern I've noticed called predictive layering. Google is combining three types of data simultaneously. There's real-time data, what's happening right now based on current phone speeds. There's historical data, what usually happens at this time on this day. And there's predictive data, what's likely to happen next based on patterns. It's like when you're at Starbucks on a Saturday morning. You know it's going to be busy because it's always busy on Saturday mornings. But if you see a line out the door, that's real-time confirmation. And if you know there's a local farmer's market that just started, you can predict it's going to be even worse than usual. Google Maps does this exact calculation for every road in America every minute of every day. This matters because traffic isn't random. It's actually incredibly predictable once you have enough data. Most people think traffic is chaos, cars going everywhere, unpredictable jams, random slowdowns, but that's not what actually happens. Traffic follows patterns. Rush hour happens at the same time every day. Accidents cause backups that ripple backward in predictable ways. Even construction zones create traffic patterns that repeat daily. And here's what makes this even more surprising. Google can detect accidents before anyone reports them. Think about that. If a bunch of phones are cruising at 65 miles per hour and then suddenly, within the same 10-second window, they all brake hard and slow to a stop, Google's algorithm knows something just happened. Maybe it's an accident, maybe a truck lost its load, but whatever it is, it's blocking traffic. And Google marks that spot red on the map immediately. Let me show you something. Imagine you're driving to Target on a Thursday afternoon. You're on a road that normally moves at 45 miles per hour. But today, you hit traffic. You slow down to 15, then 10, then stop. You're annoyed. You open Google Maps to see how bad it is, and the map is already showing red exactly where you are. But here's what you don't realize. By the time you open that map, Google had already processed speed data from 50 other phones on the same road. It had compared that data to historical averages. It had calculated that the slowdown extended for about 2 miles, and it had already started rerouting other drivers around the problem. All of this happened in the seconds before you even looked at your screen. Now compare that to what used to happen. 20 years ago, you'd be sitting in that same traffic with no idea why. You wouldn't know if it was an accident ahead, construction, or just volume. You wouldn't know if it cleared up in half a mile or continued for 10 miles. You'd just sit there, helpless, hoping it got better. That was the reality for everyone. Notice how different those experiences are? That's because Google isn't just showing you traffic, it's processing traffic patterns across millions of data points and predicting how they'll evolve. When it tells you there's a 12-minute delay on your route, that's not a guess. That's a calculation based on how fast the current traffic is moving and how long that congestion typically lasts. But here's what nobody wants to admit. This whole system only works because you're being tracked, like constantly. Every time you drive with location services enabled, Google knows where you are, how fast you're moving, what route you took, and how long it took you to get there. They store this data, they analyze it, they use it to build traffic models, and yeah, it's anonymous and aggregated. Google isn't singling you out personally, but you are absolutely being monitored. This is the privacy convenience paradox. You get incredibly accurate traffic data that saves you time and reduces stress. But the price is that your location and movement patterns are being tracked and used by one of the world's largest tech companies. Most people don't think about this trade-off. They just open Google Maps, see the traffic, and adjust their route. They don't think about the invisible infrastructure of data collection that makes that possible. And once you see this, you can't unsee it. Every app that uses location services, not just Google Maps, but Uber, DoorDash, Snapchat, Instagram, is collecting data about where you are. Some of it gets used for traffic, some for advertising, some just gets stored. But the fundamental reality is that smartphones have turned everyone into walking data generators, and companies have built entire business models around processing that data. Here's where things get really wild. Google Maps doesn't just track cars. It tracks everything. Pedestrians walking down the sidewalk, cyclists in bike lanes, buses on their routes. Every movement gets categorized. Google's algorithm can tell the difference between a phone in a car, a phone on a bike, and a phone in someone's pocket as they walk. How? Speed and movement patterns. If you're moving at 3 miles per hour, stopping frequently, and following a sidewalk path, you're walking. If you're moving at 12 miles per hour with a consistent rhythm, you're biking. If you're moving at 40 miles per hour and following road networks, you're driving. The algorithm figures this out automatically, and it uses all of that data to create different layers of information. Walking directions, biking routes, transit times, all powered by the same underlying system of location tracking. There's another sneaky pattern here called the network effect amplification. The more people who use Google Maps, the better Google Maps gets, because more users means more data. More data means more accurate traffic predictions. More accurate predictions mean more people trust and use the service, which creates more data. It's a self-reinforcing cycle that makes Google Maps harder and harder for competitors to challenge. Apple Maps tried to compete. They built their own mapping service, collected their own data, and launched with great fanfare. But they didn't have Google's decade-plus head start of collecting location data from billions of phones. They didn't have the historical traffic patterns. They didn't have the machine learning models trained on trillions of data points. So Apple Maps was less accurate. People got lost. Jokes spread across the internet, and most people went back to Google Maps. This is why, even though Google Maps is free, it's one of Google's most valuable products. It's not about charging users, it's about data collection at an unprecedented scale. Google knows more about how people move through physical space than any entity in human history. They know which roads get congested, which neighborhoods are popular, which businesses get the most foot traffic. That information is worth billions to advertisers, city planners, and basically anyone who cares about human movement patterns. Think about Marcus. Marcus owns a small restaurant in downtown Denver. He's trying to figure out where to open a second location. 20 years ago, he'd hire a consultant, pay thousands of dollars, and hope the analysis was right. Now, he looks at Google Maps data showing foot traffic patterns, busy times at competitor restaurants, and transportation routes. He makes a data-driven decision based on the same location tracking that powers your morning commute directions. So what's really going on here? It's not actually about traffic at all. It's about the fundamental transformation of how we interact with physical space. Before smartphones, you navigated the world through memory, paper, maps, and asking for directions. You learned routes through trial and error, you got lost, you discovered things by accident. Now you outsource all of that to an algorithm that knows more about the roads than you ever will. You don't learn routes anymore. You don't need to. Google Maps tells you exactly where to go, which lane to be in, and when to turn. And in exchange for that convenience, you've allowed yourself to become a data point in the largest real-time mapping system ever created. The people who understand this don't stop using Google Maps. That would be impractical. But they recognize what's happening. They know that convenience comes with surveillance. They make conscious choices about when to enable location services and when to turn them off. They understand that nothing in the digital world is truly free. You're always paying, just not with money. These patterns aren't personal failures. They're predictable systems that catch everyone. But now that you understand how Google Maps actually works, that it's not satellites or cameras, but millions of phones all reporting their speeds simultaneously, you can make more informed choices about your own digital privacy and data sharing. So here's what we've uncovered. Google Maps knows about traffic because it's tracking your phone's speed and location in real time, along with millions of other phones. It combines that real-time data with historical patterns and predictive algorithms. It processes everything through machine learning models that can detect accidents, predict congestion, and calculate optimal routes faster than you can blink. The whole system works through the crowd speed effect, turning every driver into a traffic sensor. It improves through network effect amplification, getting more accurate as more people use it. And it creates the privacy convenience paradox, offering incredible utility in exchange for constant location tracking. The question isn't whether Google Maps is useful. Obviously it is. The question is whether you're aware of what you're trading for that usefulness. Because now you know it's not magic. It's not satellites watching from space. It's you and everyone around you, constantly broadcasting your location and speed to build a real-time map of human movement. So next time you're stuck in traffic and you pull up Google Maps to check the red line on your route, ask yourself, am I just checking the traffic? Or am I also contributing to it? Because once you see how this invisible infrastructure of data collection works, everything looks different. You're not just a user of Google Maps, you're part of the system that makes Google Maps possible. And that's either really cool or really concerning, depending on how you think about privacy, surveillance, and the hidden cost of modern convenience.